as we have covered before, Rene Descartes didn't have a calculator, so he he needed to think of ways to narrow down long lists and terrible lists. What if your constant was like 3/16 or something, and your first leading coefficient was, I don't know, 1,200, I don't know, 1,024 or something. You'd be like, oh, I'm going to be here all day. Um, and he narrowed it down with this trick that we're going to use: positive real zeros. We look for the change. Let's just do that. We say plus here goes to negative. That's one change, and then negative goes to positive. So that's two. So we'd expect two positive roots, or two less than that, or less than this by an even number. So it also might be zero positive roots. So two or nothing. And why does it have to go by twos? Because we know that if there's like a root of 2i, then there also has to be a negative 2i. Irrational roots and imaginary roots come in pairs. So, but that's why it goes down by an even number. And then we also plug in. We say, what would happen if I said h of -1? And I go ahead and plug that in. That turns into a negative. This would become a negative, which would make that a positive. This would just stay the same. I square a negative, who cares? Negative. This would change this to if I put in a -1 here, that'd change that to a negative. I don't mean to say 1, just a negative. And then I can't change that from being a positive, so that's a constant. So let's see. Here's one change. Here's another change. Here's a third change. So we're saying that there could be 3 negative roots, and there could be 1 negative root, because, again, down by an even number, down by 2. Okay, so I guess we could have a chart. You don't need to draw the chart. If you tell me how many there could be of each, I'm okay with that. But just think about it. If there were 2, I don't know. I hate the idea of it. There could be, positive roots, negative roots. I don't know, and then possible imaginary roots. So, okay. So the possibilities are 2, and I can't have. I was going to say 1 or 3, but it can't be like that. It'd have to be 2, and this is. Oh, it's to the 5th. Hang on. Hold everything. It's to the 5th power. So there's a possibility of 5. Okay, so let me rethink what I just said. We got, I guess this is a good exercise. It's a possibility that we have 2 positive, and there's also a possibility that we have 3 negative, right? We said it's a possibility. And then there would be no imaginary. And then what's the other possibility? I could have 0 of these. Well, before I do that, let's exhaust the 2's. I don't really like this chart, but there could be 1, and then there'd be 2 imaginary, right? And is it possible that there'd be 3? No, because I can't have 1 negative. Yes, I can have 1 negative. Well, I already said that. I can't have 0 though. So those are the possibilities, since I have limited to. I suppose the chart is a good thing. Then I have 0 possibility here, and then it could be. There's only 3 changes that are. We might want to say, oh, there's 5. They could maybe have 5 negative, because look, there's 5. But no, there weren't 5 changes, so I can't write 5. Okay. So it kind of limits us, 3, and then that means there have to be 2 imaginary. And then the other possibility is that there'd be 1, and then there'd be 4 imaginary, okay? So you can see there's no situation where this wouldn't have at least 1 real root, okay? There might be 3, and there might be 5, okay? So here's the situation where there'd be 5 real roots, and then here's the situation where there'd be 3. Either one of these would give me 3 real roots. And then there's one last possibility where I'd have 1 real root. But there's no situation where I have 0 real roots, because these guys have to come in pairs, and I can't get 5 to happen like that. Okay, so that's instructive. The table is good. The table is good. And I will put a picture up of what exactly happened here if we graphed it.